Okay, so here's our final set of factorizations. So basically, when you're doing a factorization that involves a substitution like what we just did, you need to make sure that whatever you ended up with cannot be further factored. So in this example, we're actually going to see we'll need to factor multiple times. So this first one, x squared minus 16y to the power 4, you might notice is difference of squares. How so? Well, you have x squared squared, and you have 4y squared squared. So remember that a squared minus b squared is equal to a minus b, a plus b. That's our difference of squares factorization. So you'll notice in this case we're going to get x squared minus 4y squared, x squared plus 4y squared. Now, we're not done yet because you'll notice actually this one can still be factored. That's still a difference of squares. To make that more obvious, let's write that as x squared minus 2y squared. The other factor is a sum of squares, and usually that is not factorable, so we're going to leave it as it is. Okay, so finally we're going to have x minus 2y, x plus 2y from the first difference of squares. And then we're going to write this sum of squares as it is, and that's our final factorization. Okay, let's do another example that looks a little bit more complicated. So in this case, you'll notice you have x to the power 4, x to the power of 2, and this one is like y plus z to the power of 2 and y plus z to the power of 4. In this case, it may be tempting to expand it all out, but you're just going to make a big mess that you can't factor. So instead of doing that, we're going to make some clever substitutions to make it look like, let's say like a x squared plus b xy plus c y squared. I'm using capital letters to distinguish from the lowercase x and y in the original. So let's say, first let's make it more obvious that this is something squared. So the first term is x squared squared. The middle term is just what it is. And then the last term is like 4 times y plus z squared squared. Okay, let's do some substitutions now. It's not, I'm going to write in red because it's not mandatory, but might help you if you're struggling to see it. So let's say a is going to be x squared, and let's say b is going to be y plus z squared. When you do that, you're going to get a squared minus 5ab plus 4b squared. And hey, that's pretty easy to factor now. So you're going to find that that's going to be a minus 4b times a minus b. Okay, let's put things back, and then let's see if we can maybe still factor some things. So we have x squared minus 4 times y plus z squared. That's the first factor. Then the second factor, we have x squared minus y plus z squared. And you'll notice that we actually have, both of these are differences of squares. Okay. I'm going to rewrite the second one so it's a little bit easier to see as a difference of squares. This is going to be like 2 times y plus z all squared in the middle. So that means we're going to get 2 factors from the first factor and 2 factors from the second factor. So the first one's going to be x minus 2y plus z. And then we have the plus instead, x plus 2 times y plus z. The second factor is going to become x minus y plus z, and then x plus y plus z. Finally, to make it nice, we want to get rid of these nested brackets probably. So let's say x minus 2y minus 2z, x plus 2y plus 2z, x minus y minus z, x plus y plus z. And that is our final factorization.